Here we're going to look at question 7 from section 2 of the BMAT 2014 paper. So in this question, we're given 6 different units, and we're asked which of the following is a unit of current. So putting those up on the screen, they are amps per second, or amperes over seconds, coulomb seconds, joules per coulomb, ohms per volt, volt ohms, or watts per volt. So which of these is a unit of current? Now if you'd like to answer this question yourself, then just please pause the video now. Otherwise, let's have a go at it together. Okay, so here we've got are loads of different units mashed together to try and make this new unit of current. So what we should try and think about is what these units actually represent. So for example, what's a coulomb? Well, a coulomb is just a unit of charge, and then seconds obviously is just a unit of time. So this is charge multiplied by time, and we can try and figure out which of these is going to be equal to the current. So the best thing to do is probably to first of all think about current itself and think about which equations actually are related to current, and then we can try and compare them to this rather than going through each one and trying to work out what they are individually. So let's first think about some equations of current. Now the most basic one really is that current is just the flow of charge divided by the time it takes for that charge to flow. So for example, 1 amp just represents 1 coulomb passing through a circuit per second. The next equation which we could flash up perhaps would be Ohm's law, V equals IR, how the voltage is equal to the current multiplied by the resistance in a circuit. And then finally we could think about the power in a circuit. And the power is equal to the voltage multiplied by the current. So these 3 equations really are just 3 basic ones which all include current, and we could try and see if any of these relate to our units set up here. So let's work through them one by one. So first of all, we have amperes per second, which is just going to be exactly the same as current divided by time, right? Because amperes is just the unit of current and seconds of time. Now obviously this is a current divided by time, and so not a current in itself, and therefore it's going to be false. Moving on, coulombs multiplied by seconds, well that's just charge multiplied by time. And as we can see, this is similar to this first equation for current, but obviously not the same thing, and therefore is not going to be a current either. Now if we look at joules per coulomb, then joules being energy and coulombs being charge, this is just the energy divided by the charge. Now if you're interested, well this first of all actually doesn't look very similar to any of these equations at all, so you might actually be a bit unsure. But for those who are interested, this is actually going to be equal to a voltage, which is the work done, or work transferred or done by a unit of charge. So 1 volt is just equal to 1 joule transferred to 1 coulomb. But then obviously a voltage isn't a current, so this is going to be an incorrect statement as well. If we look at statement D, this is ohms divided by volts, or resistance divided by potential difference V. And while this might look quite similar to Ohm's law, we see that actually it's going to be the inverse, it's flipped. So this is 1 over a current, but not a current in itself. Volts multiplied by ohms is just VR, which while having V and R in it, it's not the same as Ohm's law and doesn't give a current. And then finally looking at F, we see that this is a power divided by a voltage V. So this is actually going to be the same as our last equation here. If we divide by V, then we just get this. So this is of course equal to a current. So F is going to be our only correct statement. Is going to be the correct answer which we're looking for.